Okay, today in IM1 we're going to start with 7.4, two-way tables. And in this one we're going to use a lot of mnemonics. And those are little hints that will help you remember the specifics of what you need to remember. Okay? All right. So we're going to start with a two-way table that is in your journal on page 205. And it gives you the number of t-shirts you ordered at the beginning or that you had on the hand that you had already ordered, and then how many t-shirts you have at the end. The first thing that we're going to do on this slide is we're going to complete the totals for the rows and columns. So columns go this way, and we're going to add those up. So we have, and these are really easy, 25, 30, 35, 30, and 25. And then we're going to add these totals, and these come out. Usually when you order things, you order a standard amount of numbers. The thing I want to show you specifically is that one way to check your totals is if you add this way, it will give you the grand total, and you can double check it by adding this way, which will also equal the same total. So we're just going to look at the beginning of the season on this slide, and we'll come back to this in a minute. Okay, the first thing we're being introduced to here is a frequency distribution. And what a frequency distribution is where you get your totals. Who did you interview? How many of them did you interview? What were their answers, etc. So if you can see the answers over there that they gave them a choice of, there was burgers, there was chicken nuggets, there was pizza, and there was salad. And the people that they interviewed were the 9th graders and the 10th graders. So a lot of times you'll see a frequency distribution table where it's just a bunch of slash marks, okay, after all the people that they interviewed. Okay, or you'll see it, and this is what the mnemonic that Mr. Cassidy gave us last year. If you look at a dial on a radio, it has the frequency of the radio, and it has a bunch of tally marks or lines, and you adjust your radio to what station you want. Okay, the other thing you notice is there's also numbers. Well, there might be totals instead of slash marks. Okay, so that's what you'll see with just a basic frequency distribution, and that's this part of the graph down here, the joint frequencies. Okay, so they're called joint frequencies because they're saying a female answered yes, so it's two different things. So the joint tally is 12. Okay, then we're going to go to the frequency marginal distributions, and this is when we add margins to our data chart like this, and we get the totals. So we're going to add up the columns. So we go add those up, we get 19. Add those up, we get 27. Okay, so and then we add the rows and we get 22. We add this row and we get 24. And again, like I told you before, the marginal frequencies give you the grand total. So if we add this up, we get 46. And if we add this row up, the row of the marginal frequency up, going this way, we get 46. So you can see that this all comes together in this nice little package. But now we have to learn to interpret it and understand it. Okay? So here we go. So here's how to, this is just an explanation, and you can push pause and read this. This is in your journal on page 207. It's just explaining what each part of the frequency is. So the first thing you have is your categories, and these are the specifics for your categories. And then each answer is called a joint frequency because it's taking into effect or taking into account two things. These are the freshmen that answered no. Yes, these are the freshmen that answered no. These are the sophomores that answered yes. These are the sophomores that answered no. When we add on the totals, that's when we get the marginal frequency. Okay? Okay, so let's go back to what we were calculating in Exploration 1. And you can see that I've put all the totals in here. So what's the purpose of this? Well, look at how the numbers have changed when the season is over. We have a lot left of the blue and gold, so maybe we won't purchase as many of those next year. What we see down here is, wow, we have a lot less of the XL and XXL shirts than we do of these other ones. So maybe we would order more of those or less of these. This is how store owners decide what they're going to own. That's why they take inventory at the end of every season. And it's a process where they go through the entire store and they do tally marks for every object in the store, everything that they sell, so that they can know, do I want to buy more of these next year? Do I want to cancel my order for these next year? And it's a thing that every store, every retail store does, is take inventory. Okay, so now we're going to find and interpret the marginal frequencies. We already talked about what a marginal frequency is. It's when you total up your rows and columns. Okay? And then they're going to ask you to interpret it. Well, this is the interpretation right now. We really can't interpret it beyond what the numbers are. Okay? In another case, they might ask you to interpret, what do you think? But in this case, for this chapter, they're pretty much just going to ask you, what do the totals mean? So what does a number mean? This number here means that out of the 75 sophomores that responded, 12 of them do not access a mobile phone. Okay, so that's the kind of specifics that you would want. Okay, so they want you to complete this marginal frequency and interpret it. So again, what you're going to do is you're going to add on a column for your totals. Okay, and you're going to complete the total here. You're going to find the total here. Then you're going to add these. Then you're going to add this. And then you're going to double check by seeing if these two totals match and give you your grand total. Go ahead. So hopefully you got those totals. And here's the interpretation. Like I said, it's very basic. What do the totals represent? Okay? And read through so you understand how to do those. Okay. So how to make a two-way table. So you're given a bunch of data and you need to know how to put it together. So here we go. You conduct a survey that asks 280 students in your freshman class. There's your total. So that goes here. Okay? Whether they play a sport or a musical instrument. Those are your categories, sports and instruments. And then, of course, you're going to get the answer yes or no. So you got to add those in. Those are the specifics. 118 of the students play a sport. Boom, there's a total. 118 said yes to sports. Out of that 118, and 64 of those students means out of the 118, 64 of them also play an instrument. And they don't always put in those also words to give you that hint, but it says 64 of those, of the 118, so that you would put the 64 there. Then it says 93 of the students do not play a sport or an instrument, so they answered no to both, so that one would go there. Then they want you to organize it and complete it. So how do you complete it? Well, I want you to think of a Sudoku puzzle. What information do you need to get a missing number? Well, if you look here, I've got 2 out of 3 of my numbers. So I could subtract 118 minus 64 to get this number here. Okay, I could also do this column because I have 2 of my totals. I could say 286 minus 118 will give me that number. So if you take your time and you finish, this is what it would look like. Okay? So then as you get each number, it allows you to fill out more numbers. So check that out. We're going to do an example together. Okay, you conduct a survey that asks 85 students. There's my total, whether they are in the math club or the chess club. And we're going to put yes, no, yes, no. Okay, 35 of the students are in the math club. Okay, 35. 20 of those are also in the chess club. 20 of those. Okay. 38 of the students are not in either the math club or the chess club. So there's your 38. So the first number I would look for would be this one. I could find that. 35 minus 20 is 15, right? So I could go 15. And I could do this one. 85 minus 35 is 50. Now that I've got those two, I can go on to finish this one, which would give me this one and this one. Okay, so you just keep going until you've completed the whole table. And there you go. All right. The next thing we're going to talk about is relative frequencies, the joint relative frequency and a marginal relative frequency. So the mnemonic that we use for this one is the family. Okay, we have this huge family, and each relative is one of the total, right? We have one relative out of the total of whatever, 25 people. But what if we're talking about your family and you have 5 people in your family? So your family would represent 5 out of the 25, or 1/5 of the family. Okay, you could use a fraction, you could use a decimal, or you could use a percent. I noticed that in big ideas they use decimals for the most part, but I've seen it done in all 3 ways. Okay, so this is what we're talking about. What is the specific that we're talking about? Each person. So it's a part over a whole. Okay, that is what a frequency, a relative frequency is. So the part of the whole is our grand total was 280, and 20 students played that sport. Okay, 20 of the students age 18 and older and younger played sports. So that was 20 out of the 280 people I interviewed, and that came to a percent, or 0.07. Okay, then adults over 50 and older, 5 out of the 280. That was the part that I got in my joint. That was my joint frequency over the whole, which was my total, and that would be 0.02 because we had rounded. Okay, then notice that the total of the people that did sports out of the total that I interviewed was 35, and that will give me this percentage, which is these percentages added up. Okay, so if I did this one, it'd be 0.04, and this would be 0.13. And if you add that up, it would equal 0.13. Okay, so that's important to remember. Okay, the marginal relative frequency is when you do the margin. Okay, the total for the margin over the whole. And those should add up as well. Okay? All right, so here's another example. This is in your text on page 358. I just wanted to show you what they look like in your book. So they're going to give you just the basics, and you have to find the total yourself. So if I added up my column and my rows, my total would be 680. To create my relative frequency, I'm going to take the total here and put it over the grand total, and I get 0.18. Then I take this one, put it over 0.18, and I add there. Now notice that they don't take the marginal frequencies and create them. They just add this column and get the total here. Okay, and that's okay. That's how they do it here, and that's fine. This shows us that they interviewed, half of the people they interviewed were juniors, half of the people were seniors. Okay, notice that this total adds up to this. And again, the grand total of a relative frequency distribution is going to be 1 or 100%, because you're counting up all the people and all the answers. Okay, so push pause and read this if you want to get more clarification. And we're going to go on. Okay, so they want you to make a two-way table that shows the joint relative frequency, the joint and marginal relative frequencies for this. So you can do it the way that I showed you, where you come up with the totals, or you can just go ahead and add the margins at the end. I kind of like the totals. That's the way I was taught, and it also is another way to check your information to make sure it's adding up. So the grand total was 318. So if I was going to do this, and I'm just going to do a couple of them, then I suggest you push pause and try to finish. So remember, this would be 96 over 318. It's the part over the whole. Okay, and then down here would be 54 over 318. And then the total, this one would be 150 over 318. Or you could just add these two percentages to get the total here. Okay, or the two decimals. So push pause and go ahead and give this a try. Okay, so here's what your joint and marginal relative frequencies should look like. And hopefully yours worked out. And remember that the rows and the columns should always add up to 1. Okay, the next thing we're going to talk about is a conditional distribution. And here's the definition of that. The conditional relative frequency is a ratio of a joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or a column total. In other words, instead of using the grand total as the bottom, it's a marginal total. Okay, so it's a part out of the row total or a part out of the column total. And that's where it gets a little confusing, is what are they asking me to find? So I noticed in Big Ideas they will tell you that given the row or given the column, but there's another word that you want to look for, and it's given. So this would be if they asked you to find the relative frequency for given the class. So if you look at this example here, it says given the class. So given biology, how many students got an A, how many students got a B, how many students got whatever. The total number of kids that took biology was 20. That was my total, my marginal frequency over here. So now I'm going to do the 6 total biology students that got an A over the total biology students. And so I do that for each of my grades for biology. Okay, so we're going 6 over 20, 6 over 20, 5 over 20. This will be your 100%. In fact, each column, each row is going to total 100% because we're going to calculate the conditional distribution for each row. Okay, so given the class. Okay, given the grade wouldn't make sense, wouldn't have any significance. Now, the thing I want you to notice is that each of your rows is going to equal 100%, but the numbers going this way have absolutely no bearing on each other because we're only talking about each one separately. So you won't even make a total column down here because it wouldn't have any effect on your data. Okay? So that's an important thing about a conditional relative frequency, and that's why we use conditioner, because it makes straight hair. So we're either going to go do our columns to 100%, okay, or we're going to do our rows to 100%, but not both. And that's the difference with a conditional distribution. So let's look at an example. So this is the information that we got before. We started with the major that kids were choosing, and we figured out all of our relative frequencies. So we've got those all here. But now we want to do a conditional relative frequency. So what they did is they said, use it to calculate the conditional relative frequency of each column. So we're going to be going this way, okay? So we're going to take, and what they did it a little bit differently. I showed you taking this over the total of the column, but they're just taking the percent. So they're taking 0.18% over the total of that column. And that's how they got the conditional relative frequencies for this one. So you're going to be asked to do it a little bit differently. They're going to have you calculate the frequencies first, the relative frequencies first, and then use the percentages to calculate your conditional relative frequency. And it's still just the basic thing. It's the part over the column total. Only they're taking the part decimal over the column total decimal. So it's still a ratio, and it's still doing the same thing. Okay, and you would get the same numbers if you had used the numbers. Okay, so here's the example that you're going to work on in your journal, and notice that it uses that wording that I warned you about. Given that employee prefers to go to a day game. Oh, so here is what they're saying that we're going to refer to. Then, which deck do they prefer to sit on? So we're going to do given for the rows. And they do give you that as well. They tell you based on the row totals. But they want you to figure out this answer. Given that an employee prefers to go to a day game, what is the conditional relative frequency that he or she prefers to sit in the lower deck? So they're asking you to find this percentage. Okay? So remember, the first thing you want to do is find, since we're doing rows, the totals of those rows. So I'll give you a head start. And now we're going to do 28 over 62, etc. Okay, remember that these should add up to 0.1, okay, because it's 62 over 62. So push pause and see if you can calculate this. And the answer that you want, the main answer, is this one, but go ahead and complete the chart. Okay, so given that someone wants to go to a day game, the chance is 54% that they would want to sit in a lower seat. So it doesn't seem to be very significant which seats they sit in. This is not that big of a spread. But given that they wanted to go to a night game, they would definitely want to sit lower because they would be able to see better. So those are all the kinds of data that you would want to understand in this case. Okay, so there's your grand total answer. Okay, so they want you, this last part is about recognizing associations and deciding, is there really a correlation? So it says, you survey students and find that 40% exercise regularly, 35% eat fruits and vegetables, and 52% do not exercise and do not eat fruits and vegetables. Is there an association between exercising regularly and eating fruits and vegetables each day? So what they did was they found all the relative frequencies, including the marginal frequencies, and they wanted to decide if there was a correlation. And what you found was that the people, look at here, there is an association between exercising regularly and eating fruits and vegetables every day, because you look at the frequencies and 67% of the people that exercise regularly also eat fruit regularly, and 86% of the people that don't exercise don't eat fruit. So obviously, when you make one healthy choice, it's likely that you're going to make another healthy choice. And the same goes for not making healthy choices. Okay? So, interesting correlation there. And you can read through this data. It's in your book. Okay? Okay, here's another example from your book. And it's just asking students whether they share a computer at home with other family members. And obviously your family might not live in the pattern. I know when we had 6 kids at home, we had one computer in the house. So, but, different families are different. But they're looking for, is there a trend? And so if you look at all the data and you make your frequency table, you'll see that the table shows that as age increases, students are less likely to share a computer, which makes sense because they have more need for the computer to themselves. So you can pause and read this, or you can look at this in your textbook because this is the example from the text. But hopefully that gives you a good understanding of two-way tables.